Welcome to Study Loop.
All right, let's talk about band theory. Before we can talk about what a band is in band theory, we need to first understand how band theory works. So let's consider for a second a single lithium atom. If we think about that lithium atom and we think about the lithium atom's valence shell, so that 3s orbital that lithium has, it's going to have this one block, and we can put an electron in there. Now let's think about a dilithium molecule. Now we've got two lithium atoms, each contributing an electron. What these two are going to do is they're going to have, there's now two orbitals that these electrons can sit in. As we know, electrons like to occupy the lowest energy orbitals in their ground state. So the two electrons from dilithium are going to be in these two lower orbitals. Let's jump ahead and consider a tetratlithium. So this tetratlithium is going to have 4 electrons, but it's also going to have 4 orbitals. You might notice a pattern here. So when we're talking about these on this finite scale, we have these bonding orbitals that have the electrons in them. We have these non-bonding orbitals. Now we're thinking about these on numerical things that we can quantify. Let's consider for a second that we have an infinite number of lithium atoms. In other words, what you more or less can consider having if you have a solid piece of lithium metal. What's going to happen here is there's going to be so many valence orbitals on this within this metal that it's just the energy level differences are going to be so close to each other that you can't really tell the difference. And what's going to happen is you're going to end up with sort of this one block of orbitals, another block of orbitals. And the electrons are primarily going to occupy this lower area down here. And this is where we talk about this sea of electrons that we can consider metals as having. And when we think about these two spaces, this is where we get our two ideas for band theory. So this is our valence band. This is going to be the band that the electrons are mostly spending their time in. Then we also have this conduction band. And when electrons pass up into the conduction band, it means they're able to pass around within that conduction band, and they can then more easily conduct electricity. So energy promotion into the conduction band promotes the flow of electricity. And metals, because there's no gap here between these two energy levels, electrons can freely pass between these two levels, meaning that conduction is something that can happen very, very easily. If you consider this for semiconductors and insulators, there's going to be a gap here actually between the valence band and the conduction band, and it's going to prevent this easy flow of electrons. And for the case of a semiconductor, we need to have some sort of input to make them conduct electricity, and insulators, the band gap is too high. So just to summarize, band theory is the summation of the orbitals contributed by the atoms within a metal solid. And specifically for metals, the lack of gap between the valence bands and the conduction bands is what contributes to their overall well conduction of electricity.